Let's begin our discussion with the rational function. So what is a rational function? A rational function is a function which is in a form of f of x is equal to a number on top divided by, it can be anything down here, but x has to exist on the denominator. It can be like that. As long as on the denominator you have got x, then that is a rational function. We are not interested with the numerator. The numerator can have x or can just have a number. It's okay, but as long as the denominator has got x, then that is a rational function. Now, under rational function, let me first teach you on how to find the domain and range. Then we'll come back for sketching. So under rational function, we know that you can never have a number over 0. This is definite and defined. It's not possible. You can't have 0 on the denominator. Therefore, to find the domain of a rational function, you need to get the denominator. So I'll put it here, domain. You need to get the denominator. You set it not equal to 0. Then you solve for x. For example, the first question which you have here is negative 4 minus, or negative 4 over x minus 2. So you just get the denominator only x minus 2 not equal to 0, because the denominator cannot be equal to 0. If it's 0, then it is undefined. Okay? Then from there now, we're going to say, we're going to solve for x. Shift 2 to the other side, x not equal to 2. Meaning that the domain, it can be any number except 2. So any number you can plug in here is going to work out except 2. Because if I put 2, it's going to be 2 minus 2, 0. So we don't want to have 0 on the denominator. So now how do you write this domain? You don't just end there, no. So you can put it either in set interval notation or in set builder notation. So in set interval notation, you say the domain will be from negative infinity not included all the way to 2, but 2 is not part of the solution. So that's why it's just open. Union from 2 to positive infinity, like that. If you're not okay with this, you can also use set builder notation, where you say the domain will be x is such that x is not equal to 2, comma, but x should be a member of all real numbers, like that. In some other books, they are going to tell you that it can be written as x is such that then x a member of all real numbers, then comma x is not equal to 2. It's the same thing. So you can either choose that or that. It's the same thing. So you can either represent your answer in set builder notation or in set interval notation. But it depends with what you are comfortable with. So if you're okay with set builder notation, you can use it. It's fine. Any question there before we proceed? Any question? We're okay? So see, you don't okay. Now how do we find the range? To find the range, I want you to understand one thing. I know sometimes you come up with that method of saying, no, let's first find the inverse of the function. But finding the inverse of the function, yes, it's okay if you're okay with that. Okay, let me teach you two. So, for example, the way these ones, it's easy for me to find the inverse. So if I'm to find the inverse here, it's going to be y is equal to negative 4 divided by x minus 2. So if you find the inverse, then you find the range the way we are you find the range the way we are finding the domain. That will be the range. Now, I'm going to use the inverse method just for the first part, then the rest I'm going to teach you another method, so you choose which one to go with. So here let's make x as a subject of formula. So we cross multiply, we end up having xy minus 2y is equal to 4, negative 4. Shift negative 2y to the other side. I will remain with this. Divided by y, divided by y. So these will cancel and we end up having x is equal to negative 4 plus 2y divided by y. Now, since you can't have the 0 on the denominator here, so you can say that the range, when you reach at that point, then you say y should not be equal to 0. You just get the denominator when you reach at this point, then just set it not equal to 0. So in that case, meaning that the range is from negative infinity to 0, union 0 to positive infinity. Or I can say range y is such that y is not equal to 0, but y is a member of all real numbers. I know, guys, you know the method for finding the inverse, right? Okay, so now I want to teach you another method, because this method, sometimes if you don't have time, it will be a bit challenging for you. Now there is what we call only two things. I just want you to know only two things. There's what we call bottom heavy. When a function is bottom heavy, like when it comes for finding the range and the domain for your level, you come across this type. The way this function is, I want us to compare with the way this guy is, those two. So we have got f of x is equal to negative 4 divided by x minus 4. This function on top there, on the numerator part, we don't have any x, but on the denominator we've got x. So this function is bottom heavy. When we say bottom heavy, we mean the denominator or the x on the denominator has got the highest power of x than the numerator. Is that okay? So that's what we call bottom heavy. When you come across any function, as long as the function is bottom heavy, the power of x on the numerator, on the denominator, is higher than the power of x on the numerator. That function is bottom heavy. Then the range is y is not equal to 0. You don't have to do anything. Another scenario, let's say you have f of x is equal to negative 4x plus 1 or plus 1 divided by 2x squared minus 1. Is this function bottom heavy? Yes, this function is bottom heavy because the denominator has got the highest power of x than the numerator. Even here the range is y is not equal to 0. Okay? So you just compare the x, the powers of x on the numerator and on the denominator. How are they? Okay? Then there is also, let's look at part 2, which is f of x is equal to 6 minus 2x divided by 1 minus x. The way this function is, the power of x on the numerator is equal to the power of x on the denominator. So this function is not bottom heavy. It's not top heavy, it's not bottom heavy. The powers or the x on the on top, they are the same as the powers of x on the bottom. Therefore, the range in that case, what do? You divide the coefficient of those x having those powers we are talking about. In this case, the coefficient of this guy is negative 2, here negative 1. So I'll say the range will be y not equal to negative 2 divided by negative 1, which is just negative 2. If you are not okay there, let me know so that I repeat myself. So the numerator and the denominator, they are having the same power of x. Oh, yeah, your network is really bad because you are responding after 5 minutes. So your network is not stable. So we are saying that, but you're okay with the first part, right? The one I'm from explaining when the function is bottom heavy. Hmm? Okay. So now the part where I am right now is the top part and the bottom part. They are having the same degree of x, the powers of x in short. So this is power 1, this is power 1. That's why I'm saying the powers are the same. Okay, so if the powers are the same, the range, you divide the coefficient. Okay, let me teach you this. Let me note, y is not equal to, just get the way it is, negative 2x divided by negative x. So x and x will go. That's why we are just saying you just get the coefficient. So it will be negative 2 divided by 1, negative 1. And you end up having negative 2. Can you mute your mic? David. Okay. So you end up having 2 as the range. So how do you show this in set interval notation? You say, yes, please. Are the same. Yes, yes. Okay, we are coming there. Yes. Okay. Mm, so the range, like I said, negative infinity to 2 not included, 2 not included to positive infinity. Or you can put the range in set Buell notation. So use y is such that y is not equal to 2, but y should be a member of odd real numbers. As simple as that. Now guys, before I continue, okay, at your level you are not going to be given any function which is top heavy, then they ask you to find the range, like the question our friend is from asking. Have you seen the way this question is? They can't ask you that unless when you reach in second year. It used to be there. If you check the past papers for 2008, yeah, it's there, but it's no longer part of the syllabus. You get my point, eh? So the one who was asking, I'm sure you have you have gotten it now. Yes, but in second year, especially those who are doing actual science, pure mathematics, engineering, you're going to do that one next year. So before I even move to, okay, if I may ask guys, what is the domain for this guy here? Just by looking at it, 3 over x minus 2, what is the domain? Let's do fast. Mhm.
Sorry to disturb you. I didn't get anything on question two because my network was misbehaving.
Okay, you are going to get it on question 3 since it's the same thing.
Okay, okay,
Yes.
okay, sure.
Yeah. So question 4, but for question 1 you're okay?
I didn't get anything. Question one, question two.
No.
It's just
Then are you sure? Are you sure your network was not okay, or maybe you have just joined now?
no. I haven't joined now. I've joined later, but it's just my network. It wasn't showing anything, and even the what. I didn't hear you saying anything, but the screen was there showing, but it wasn't showing like in the way it is now.
You stay by ruins.
No, I'm staying at lecture compound.
Oh, that side. Zamtel is really bad that side. Okay, it's fine. You are going to get it since question 1 and question 4 they are the same. Then question 2 and 3 they are the same. So you get it from there. It's fine.
Okay, sure.
Yeah. So we said if you have been given a function, a rational function, when you want to find the domain, just get the denominator, set it not equal to 0, solve for x. So that's what we have been doing so far. So I'm asking you not what would be the domain for that question I've just highlighted in red for question 4. Okay. Okay. And then question 3. Yes, question there. Hmm. Okay. So I said they can't ask you this. So when you reach at this point, then you say the range is equal to from negative infinity to 2, not included union, 2 to positive infinity. Or you can put it in set beta notation where you say y is such that y is not equal to 2. You can mute your mic like that. You can mute your mic. Okay, then is it Ndumba? Your video is on and you are dancing in the background. So you can just turn it off. Bwana Rumana. Okay, thank you. So we're okay now there, right? Now, guys, I want you to understand sometimes you're having challenges on how to find the asymptote. Like in this question here, they're not asking anything about the domain. But one thing you need to know is that when you're talking about the domain, so I'll write here domain, then I'll write vertical asymptote. I'm going to give you the first question where we said you say x minus 2 is not equal to 0, then you solve for x is equal to 2, or it's not equal to 2. That's what we say the domain is. Vertical asymptote is the same thing, you only remove not equal to, so it's going to be x minus 2 is equal to 0, then x is equal to 2. In short, you just remove this comma part not equal to should be equal to. That is a vertical asymptote. So if you know how to find the domain, then you know how to find the vertical asymptote. Okay, that's why I had to start from domain. So when you know how to find the domain, you just get that answer. You say x is equal to that number. That is your vertical asymptote. If you know how to find the range, then that is the same as the horizontal asymptote. You only say, in this case, it's going to be y is equal to 2. That is my horizontal asymptote. It's the same as the range. You can only unmute yourself if you want to ask the question, because you are disturbing us now. Moyo, your mic is on. You can just mute yourself. Okay. So now,
I'm not able to do follow-up. That's the network.
no, you are not supposed to be complaining about the network, because after this class, I'm going to upload this recorded video and you'll be able to watch it because I'm recording.
Sir, I've got a question. I
Please
can't
ask.
see anything at presented.
Yes, you can't see anything,
Yes,
right?
I can't see. I'm just seeing Transcendent Institute. That's all.
Oh my god.
I can't see what you are actually teaching. Yes. Thank you.
Ah, you are the two of you complaining in the background. Okay, do this. Can you just try to leave the meeting and then join again? I think you'll be able to see it. You guys,
Okay.
are you using Zamtel? Okay, okay. So are we okay now on how to find the vertical and horizontal asymptote? Or maybe I should repeat.
Sir, can you find vertical
Oh my god.
asymptote and horizontal asymptote?
But you're okay with the domain and range, right?
Yes, and then with the test.
So now I'm saying the way we are finding the domain, we are saying that this guy should not be equal to 0. But in this case, when we're finding the vertical asymptote, you just get the denominator. X minus 2 is set it equal to 0. So for x is equal to 2. So my vertical asymptote is that x is equal to 2. What of horizontal asymptote? Horizontal asymptote, you just check, is the function bottom heavy? In this case, the function is bottom heavy. If I want to find the range, I'm going to say y is not equal to 0. But since I'm getting horizontal asymptote, y is equal to 0. It's the same thing. On that the domain, I'm going to say this is like this. Now since I'm finding the vertical asymptote, that's why I'm saying it's equal to 0. It's equal to 2. Then for this one, the vertical asymptote for this one is x is equal to what? 1. Because you're going to say 1 minus x. Let me just solve, because you'll be like, me, I didn't get that part. So 1 minus x is equal to 0. So for x, shift this guy to the other side. It's the same as just shift x to the left, to the right hand side, shift 0 to the other side. So it will be 1 is equal to x. This is the same as x is equal to 1. That's my vertical asymptote. At the same time, that's my domain, x not equal to 1. I think I want you to get the logic there. We're okay, right? Hello.
Yes, sir.
So then I'm going to say, if I know how to find the domain or the vertical asymptote and horizontal asymptote, so now here the horizontal asymptote will be what? Y is equal to 2. It's just, you just divide. Y is equal to negative 2 divided by negative 1. So y is equal to 2. That's where this 2 is coming from. Since the numerator and the denominator, they're having the same power of x, you get the coefficient negative 2 divided by negative 1. Okay, I want someone to tell me what the vertical asymptote is going to be for this guy here. Not vertical, horizontal asymptote for this one. Fast, quickly. Uh-huh.
What is that?
It's going to be what? Okay, perfect. What is the horizontal asymptote for this guy here? You think? Okay, yeah, it's zero. So now, after knowing how to find the vertical asymptote, the horizontal, the domain, and the range, then the only remaining thing is to find the intercept. How do you find the intercept? We'll come for sketching. Now, I'm going to start with the first one. Allow me to put these things here. I'm going to put it here to say, this question is saying, sketch the graph of the following function, clearly identifying all intercept and asymptote. They're not asking about the domain, but another question they can ask, sketch the graph of the following function, clearly or clearly indicate all the asymptote or all the intercept and asymptote, and also find the domain. That's when you are going to say the domain is equal to. But the way this question is, they're just asking about the intercept, sketching, and the asymptote. So you start with what? The vertical asymptote. You write VA. If you want, you can write the full word vertical asymptote. Then you come. You say you get the denominator x minus 2 is equal to 0. X is equal to 2. That's your vertical asymptote. Again, horizontal asymptote. No one is going to question you, even if you copy from someone here to say the function is bottom heavy, therefore y is equal to 0. No one is going to question you, where are you getting this 0? Because they know that you know that when the function is bottom heavy, the horizontal asymptote is 0. Let's go back to asymptote. How do we find the asymptote? Oh, sorry, the intercept. So we have got what we call x-intercept and y-intercept. To find the x-intercept, this function here is the same as I have got y is equal to negative 4 divided by x minus 2. To find the x-intercept, equate y equal to 0. Solve for x. So where there is y, I'm going to put 0. 0, negative 4 divided by x minus 2. I cross multiply. Negative 4 is equal to 0. This is not true. Negative 4 can never be equal to 0. When you reach at this point, x is not, you can't see x here on the final part here. So you just say no x intercept. There is no x intercept here. Now, another way on how you can know that here I'm going to have x intercept and here I'm not going to have x intercept. If the numerator has got x, then you expect to have x intercept. If the numerator doesn't have x, you don't expect to have x intercept. You are going to have no, you're not going to have any x intercept. So this question here, do you expect to have x intercept for the last question from the explanation I've given you? What of this one? Yes. So as long as on top there is x, you expect to have x intercept. When you are solving any question for rational function and you are sketching, you have been told that you need to indicate all the intercept. If you see that on top there is no x, show them. Definitely you know that the answer is we are not going to have x intercept. So how do we find the y intercept? To find y intercept, I'll put y is equal to the function x has to be equal to 0. Where there is x, put 0. Y is equal to negative 4 divided by 0 minus 2. So y will be equal to negative 4 divided by negative 2, which is 2. What does it mean? When x is 0, y is 2. That's what I have. Who is behind here on how to find the intercept before we sketch? Uh-uh. On the x-intercept. But are you okay on the y-intercept? I was cross multiplying here. I said this 0 is equal to negative 4 divided by x minus 2. So now crossing multiply, you know that here is the same as divided by 1.
Yes.
So negative 4 is equal to 0 times anything here is 0. You understand?
Yes.
Yes. That's why we say there's no x-intercept.
Okay, thank you.
Sure. Now, since I've reached at this point, I can now sketch. I'm going to sketch it from here since I don't have enough space this side. Okay. X-intercept, I'll start first. My x-intercept is at 2. X is equal to 2. Put 2 here. Put this guy. You put a dotted line. You are going to ask me why is it that the graph is bending. It's bending because I'm just sketching, so it's not accurate. Anyway, so then the horizontal asymptote is in y. When you say y, it's going to cut at this point here, this line. Now, do you have intercept? X-intercept we don't have. Forget about it. Let's go to y. Do you have y-intercept? 0, 2. 2 is where? Let me put it. I'm going just to put 2 there. So the point is at 0, 2. 0, 2 is here. I only have 1 point. What does it mean? This is asymptote. This is asymptote. So it has to start from this asymptote, touching this line, coming closer to the asymptote on top there. Starting from here, touching this point. Now the graph has to be neat. Touching there, going like that. I put an arrow because I don't know where the graph is ending. The opposite of this guy here, this part, now the opposite part, which is this side here, I have to reflect it. So it has to be reflected that manner. That's the graph of this guy here. Unless you have got questions. There is no exam without graphing rational function. That's what you should know. Test 2, you are going to find it. In quiz, yes, it can come. Now, I'm going to teach this together with the question 18, which is saying the modulus. The same question, now there is modulus. What does it mean? When there is modulus, the part where the graph is going to the negative side, reflect it just the way it is, but just reflect it to the positive part. So it has to be reflected like this. What I'm doing here now, I'm solving this question. I'm reflecting it just like that. Then you leave this in dotted form. That's why you have to be going with a pencil. So the graph I'm showing you right now is the graph of the modulus of this guy. You understand? Is that okay? You know, we say in Tumbuka they say kachete chete. Ah no, is it chewa? Kachete chete sausa nyama. So you are quiet means it can mean two things. It's either you have understood or everything is just VP tache. Let's solve this one, the last one. So this one, since we have already come up with a vertical asymptote, and we said the vertical asymptote is at x is equal to 1. Horizontal asymptote, who can tell me the horizontal asymptote? Y is equal to what? Y is equal to 2. Thank you. Let's go ahead and find the intercept. Do we expect to have x-intercept before we even solve?
Yes,
Why? Why?
because there's a X on top.
Exactly. So you even see the way we are solving up, as we are going to solve, definitely we have to expect the x-intercept to be there because there's x on top. So I will say x-intercept. So y has to be 0. So the equation is y is equal to 6 minus 2x divided by 1 minus x. Where there is x, or where there is y, sorry, put 0. 0 is equal to 6 minus 2x divided by 1 minus x. We cross multiply. Crossing multiply here, 0 times everything here is just 0. But I'm going to start with this one. So it's going to be 6 minus 2x is equal to 0. Shift 6 to, shift 2 to the other side. 6 is equal to 2x divided by 2 divided by 2. This they will cancel. X is equal to 3. So my intercept is that x is equal to 3. What does it mean? When x is 3, y is 0. That's what we have said. Y is 0 here. After writing this, I need also to write that as a coordinate. Then now go to who is behind here on how to find the x-intercept before we go to y. Hello. Y-intercept.
Yes.
X has to be 0. So I'll say y is equal to 6 minus 2x divided by 1 minus x. Where there is x, put 0. Y is equal to 6 minus 2 times 0, 1 minus 0. Y is equal to, so this is going to be 6 divided by 1, which is just 6. So when x is 0, y is 6. Okay, those are two different scenarios now. So I have this guy, I also have that. To make things clear, let me just put it here a bit. Okay, first thing should be your asymptote. The first asymptote is at 1. I'm going to put 1 here and draw a dotted line cutting where there is 1. Y is at 2, so the asymptote, I'm going to put 2 there. I'll say that is my 2, like that. After that, go to x. X-intercept is 3 comma 0. In x there is 3, so I'm going to put even 3 here, comma 0, which is just here. Okay, what of the y-intercept? The y-intercept is 0 comma 6. 6, it can be somewhere here. Let's just put it there. So 6 comma 0, it is here. This one, there's nothing like refracting. It has been reflected by itself. So from the asymptote here, touching this point, coming closer to the asymptote, you put an arrow. Even here from the asymptote here, touching this point, getting closer to the asymptote, you put the arrows. Don't forget to put the arrows because you don't know where the graph is ending. The graph which I've given you is a graph of f of x is equal to that guy. Now, what if we have been given the same function but there is modulus? What does it mean? Where there is, where the graph is going, as long as it is to the negative side, reflect it to the top part. So this, the whole of this part, the negative, until at that point I'm going to reflect it to the part here, top part, just there. It goes like that. As simple as that. You don't have to stress yourself. I'm done. Someone is going to ask me, why is it crossing the asymptote? It's crossing the asymptote because of the modulus. Initially it was not supposed to be like that. I'm not reflecting this part because this part is not to the negative side. The only part which is to the negative side, it is this part. It's the one I have to reflect it to go on top. So when writing math, go with a pencil at least. From what we have done here, I believe you can do part 3, part 4.
Sir, sorry, can you just repeat the modulus part and the reflecting part?
Okay, so on the reflecting part, I said since this is the normal graph was going in this direction, so the modulus means that it can't go to the negative. So this line demarcates us, it tells us that from going this side is negative. So as long as the graph is going that side, it has to be refracted on top. So I have refracted this part here to just from there to go there. Then I need to leave this guy in dotted form to show them that initially it was supposed to be like that, but because of modulus it has gone on top.
So the asymptotes that you put at the beginning, the dotted lines, they don't matter in
No,
case of modulus?
they don't matter.
Okay.
Yes, you can do it the normal way if you want, then later on you refract, or if you want you can just be going with the modulus, but it's the same thing, nothing is going to be complicated, it's the same thing. I want you to go and do 3 and 4. You go ahead and find the domain, oh sorry, the vertical asymptote, the horizontal, the intercept, and sketch. So you sketch part 1 is going to be sketching the normal one without modulus, part 2 meaning you're answering this one. Next you do that one, then you come here. I'll need, how many are you here? You are 25. So I'll need the answers before 20 2250. For 25 people you should include your name. Okay,
So can you just show the questions you should answer again?
Re-answering, sir.
so let me show you the questions we should answer. So you are going to send me the answers today, no excuses. You're answering question. Okay, you're answering this question, this one, this one, and that one. So Kylie, answering this one, you say, so for example, you're going to say f of x, this is going to be more like 1. So when you find the answer, you sketch, then 2 is going to be for the modulus one. Then again, this one also for the modulus one, like that. I'll need the answers.
What time are we submitting?
You are submitting before 23. You can submit anytime before 23.
Okay.
No, in my DM, so that those who have missed it, they are not going to. I just want them to be shocked.
Okay.
You can send them in my inbox, it's fine, I'm okay with it. But are we all in the math assignment group?
I think you should send the link or something
Yes,
to
okay,
the
let me send the link in the group for the math assignment. It's going to be easy for us to discuss from there. Okay, so you send the answers in that group. I'm going to send the link right now for those who are not in the group. Okay,
Okay.
yeah, okay. Thank you guys. Tomorrow, before you go, just a minute.